Okay, class. Everybody should be on this page right here. Okay, one more time. Everybody should be on this page right here. You're not on that page. Yeah, I see you nodding your head, but it's not there. There you go. Yes.
So this is how my cousin. So he was on the motorcycle and he literally and like my cousin has a whole bunch of motorcycles. He got sponsored. He's about almost the same age as me. You know him.
Yes.
And
Zoe.
he flew off his motorcycle and got hurt very bad. But
And I bet he's still racing.
he went right back up and he won too.
Good.
Well, I think
Good.
second.
Okay, guys, let's share more of these stories later. I like the stories and I like the point of them, okay? So let's work on some math. Ariana, do you have a question about math? You have a story? Well, share the story with me later, okay? Let's work on our math now. So, you guys will recognize this. It looks exactly like the ones that we already started, right? The ones we already did. We did halves. We did thirds. Now we're on fourths. Looks exactly the same, right? Looks familiar? We went over it again yesterday. I know not everybody was here, but we went over it again yesterday. So make sure that when you're looking at this, for one, fourths, let's also change colors. Oh, it's a little hard to see. You're going to label each section of the fraction bars. Then, remember, you're going to find fractions that are equivalent to 1/4 and 3/4. And you'll see those down at the bottom. The goal is we're still looking for equivalent fractions. We'll see them right down here, okay? And then we're going to do a building fractions page. But let's take a quick look at this one together, because I want to just remind you guys, I'm not going to write these down here until we go over the whole thing together, but I want to remind you guys, your denominator is how many sections your whole is divided into, okay? So in this case, the whole, every single one of these long fraction bars, they are the same size, correct?
Correct.
Yes. So in this case, we'll start out at the top. How many parts do we have? How many parts?
2.
What's the fraction then for each one?
1/2.
1/2, right? 1/2 and 1/2. Okay? 1/2 and 1/2. So if you have started this and that is not what you have written down, make sure that it is what you write down. None of these single sections should be anything other than a 1 as your numerator. The denominator is how many parts you have total. Okay? So make sure that's what you have on here. And then, remember what I said, because you are looking for fourths. Remember how we drew those lines down the page? Well, in this case, you're going to draw a line down from where the 1/4 is and where the 2/4 are, okay? We'll take a look at that. Well, let's take a quick look. How many are there right here? 4, yes? Do you need to sharpen? Question?
How can the camera see the board?
The camera sees the board, but we're actually recording the screen separately. I'll show you what the video looks like for this. Do you need to sharpen? Go ahead. So, how many parts do I have right here?
4.
How many?
4.
Yes. So, what's our denominator? Savvas. Said 4? Everybody said 4?
4.
Okay, so that means, what's the numerator for each one of these individually? What is it, guys?
1.
That's right. So each one of these is what now?
1/4.
1/4. So, because you're looking for 1/4, for something equivalent to a fourth and something equivalent to 2/4, so what it says at the top? It says 1/4 and 3/4. Excuse me. 1/4 and 3/4. We're going to take a line and draw it down from 1/4. Then take a line over here and draw it down from 3/4. And that's going to help you figure out which ones are equivalent. Okay? So we're going to work on that. Now, really quickly, guys, flip to the next page. Go ahead and chart it. And let's look at this building equivalent fractions page. Everybody go ahead and flip to this one. Everyone flip to this one. Ian, flip to this page, please. Building equivalent fractions. It's the next page. Everybody should be on this one while we go over really quickly. Okay. Building equivalent fractions. You're going to shade in the rectangle to represent the fraction shown. I mean, the fraction right here. And then you're going to fill in the equivalent fraction on the other side. Okay? So in this case, if it's 1/2, what do I do right here? What do I do there, Ayana? That's right. Jack, what do I do on this side? That's right, color in 3 of them. Schmidt, what's the fraction on this side if I've colored in 3?
No. 6 and then 3 out of 6.
That's right. 3, 6. See? Not bad. Right? These aren't bad. Yeah, see a thumbs up. Good. Thumbs up if you guys feel okay about these. Yeah? Good. I'm hearing some people say yes. That's good. So I don't think it'll take very long for you guys to get through these. And I think, yep, that's it. We only have the 2 right now. Now, there was something from yesterday that we were going to continue going through. So that was this back page here. So we will go through that as well. If you did not finish this back page, I want you to work on that too. So what we're going to do is we are going to work until about 9 o'clock. That's about 20 minutes from now. We're going to work individually. 20, maybe 30 at the most, okay? So between 9 and 10, we will come back together, and then we will go over everything. So what I want you guys to do is as soon as you're done with those 2 pages, the 4th page and the building equivalent fractions page, go back to anything you didn't do from yesterday, okay? And then we will go through all of it together. Same rules apply, though. If I come around and you ask me a question about something we just went over, I'm not going to be all that happy. Okay? And if you don't have written down what we just did together, right here, then you really are hurting yourselves. Because I do this to help you guys, okay? To give you something to work from. So make sure you are paying attention, okay? I have no problem answering questions, and I know that not everybody understands math the same way or as easily as some other people, okay? But I want to see you try. Honestly, I'll say it again. I'd rather have you put down a wrong answer than no answer, okay? I want to see you try. Okay? So let's go ahead and get started. Okay, guys, we are going to go and go over this. So I want this page pulled up first. We're going to finish going over this one together. And then we will do the other. So, especially for those of you who weren't here who might be a little bit confused, please make sure that you're following along. Okay? Now, what's your question, Aiden?
I want to see if the other one was done.
You want to see if it, well, we're going to go over it in a second. You can check yourself.
The other page that we did yesterday.
The one that we did yesterday?
Yeah.
What about it?
It's the one to see.
Oh, good. Well, I'm glad to see that, but I want you to check it when we go through stuff, okay? Okay, guys, go ahead and go. Abigail, what's your question? Yes.
Can I share the picture?
Yes, please do. Quickly. Okay. So everybody should have this page out in front of them right now. Who's got this page open? I need this page in front of every person in this room. Joel, that includes you. This page needs to be open in front of you. So we can go through it together. Guys, listen. One of the reasons we do it together is so that you can double check your work and also so that you can share your answers. If you're confident enough to be on a different page, then I want to know what the answers are that you have. So go ahead and check it. Okay. So let's take a look at this one. We already got it started, right? We know that first bar is the 1, the whole. We know the second one is the whole divided into 3. Excuse me. 2. Next one, how many parts do we have? How many parts do we have there, brewer?
3.
So what's our denominator? So what's the fraction for each one of those? 1/3. That's right. 1/3, 1/3, and 1/3. Now we already did the fourth, and we drew the line down. And I'm going to show you guys again why I had to draw the lines down. But let's finish filling these in first. Now under the 1/4 section, the fourth, we have 1, 2, 3, 4, 5. So what's our denominator there? What is it?
5.
And each fraction is what?
1/5.
1/5, 1/5, 1/5, 1/5, and 1/5. Okay, 1, 2, 3, 4, 5, 6. What's our denominator there, Jed?
6.
And Tava, what's our fraction for each section?
1/6.
1/6. That is correct. 1/6 all the way across. Each one of these individually, on their own, by themselves. Now, bottom line, bottom bar there, Jack. 8. So then, guys, what are my fractions for each section?
1/8.
1/8. 1/8 all the way across. Each one of these. Now, the goal for equivalent fractions when you draw them out like this, or when you use the number lines or the fraction bars, our little brick wall here, I think is what Madeline called it. The goal here is that you're lining things up, right? So that's why I had you guys draw the lines. Let's use a different color. Let's try this one. So here's the line again, right? Because the first one we're looking for is what would be equivalent to 1/4. 1/4. So just one section, one of these. We drew a line all the way down. So I'm going to tell you right now, if it goes through any of them, not going to work. Those don't work. But look what lines up though. Those do. And that would be the equivalent of saying 1/8 plus 1/8. So Madeline, what's 1/8 plus 1/8?
2/8.
2/8. So that is the only equivalent fraction that we have there. Now we could keep going, right? Couldn't we keep going? Remember those patterns we found yesterday? Abigail, please sit all the way down and be focused on this page. Sharpen. Go ahead. Is this page on in front of you? Better be on this page. Yes, I see you, Tal. I'm talking to Abigail. Is this page open in front of you? Looks like it's not. Open this page. I already said. So remember the patterns that we found, guys? Let's look at some of those patterns. What's going on with our denominator? What's it going up by, Ariana?
4.
It's going up by 4s. So what's our next one then? If we have 4, 8. What's after that? If you're counting, skip counting by 4s. Jack? 12 is the next one. But look at the numerators. What are they going up by? Schmidt?
I meant 3s.
They're not going up by 3s on the numerator.
I meant, sorry, 1.
Yeah, so the next one is 3, I think is what you're trying to say. Just stuck on 11 again today.
Yeah.
1, 2, 3. So then we know that our next numerator will be 4. The next one will be 5. The next one will be 6, right? But what about those denominators? We said we're skip counting by 4s, right? So what's the next one after 12, Aiden? If you're skip counting by 4s? 16. And what's the next one after 16, guys? Schmidt?
11, I meant 12.
What was after 16? Are you sure?
20, I meant
20. Yes. Jack, what's the next one after that?
24.
That's right. If we were going to keep going, Madeline, what would be the next one after that?
We're stuck on 11 somehow, and it's 28.
28. Good. Now, there's another little hint here, too. There's another pattern. So you guys saw the pattern with skip counting by 4s. You saw the pattern with each of the numerators going up by 1. But there's another pattern too. What's 28 divided by 7? What's 28 divided by 7, guys? Anybody know? No, 28 divided by 7, Ariana?
4.
It's 4. What's 24 divided by 6? What's 24 divided by 6, Malik? Nope, 24 divided by 6.
2.
Nope. 24 divided by 6, Schmidt.
11. I'm at 3.
Nope. 24 divided by 6, Jack.
5.
Guys, there's a pattern here.
34.
Abigail, what's 24 divided by 6?
4.
4. What is 20 divided by 5?
4.
What is 16 divided by 4?
4.
What is 12 divided by 3?
13.
Please stop coming out with numbers that are not correct, please. That doesn't help. 12 divided by 3.
4.
8 divided by 2.
4.
Every single one of these denominators divided by their numerator.
4.
What's that?
4.
4. Every single one of these. Every single one. Divided by their numerator. Every denominator divided by the numerator. And this pattern will equal 4. See what I mean? We just identified 3 different patterns here. You guys see that? Does that make sense? Now let's look at 3/4. It's going to be a little bit different. So with 3/4, now we drew a line straight down from the 3/4 section, right? So let's take a look. Now we want all 3 of these. That's our new bar, right? And we got 3/4 because it's 1/4 plus 1/4 plus 1/4, right? Now if you draw the line all the way down, looks to me, these are out. None of those line up, right? But this looks exactly the same. This bar lines up perfectly. You see that? They line up perfectly. If you shade those in, they look exactly the same, right? But this is 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8. We have 6 ones. What's the fraction become then? Jack? 6/8. That's right. So the only one up there that works is 6/8, but that doesn't, of course, mean that that's the only one that exists. It's just the only one that's up there. Now look at the pattern. Is the pattern the same for the bottom? Aiden, sharpen. Go ahead. Madeline, is the pattern the same for the bottom? For the denominator? Yes? Everybody agrees on that one? Okay, so once again, we're looking at 12, 16, 20, 24, 28, and so on, right? But what about the top pattern? It's different. The top pattern is different. We're not going 1 up each time, are we? What are we going up, sellers? Starting on 3, 6. What happens next?
4.
3, 6. What do we skip counting by, Sava? That's right. 9 is next. So what do we skip counting by, Sava? Numerator.
3.
That's right. 3, 6, 9. What's next, guys?
12.
What's next?
15. 18. 21. No, yeah, 21. 20.
So, in this case, though, because we've got a 3 on top for our original numerator, we can't say 28 divided by 21. We're not going to get that. That pattern's not there. But what pattern is there is this one. We can get every one of those to come back down, right? Based on how many we have here. So what is a common factor here that will get us back to 3/4? What's 21? What is 21? First, what's 21 divided by 3?
7.
7? So then what's 21 divided by 7?
3.
Well, it's 28 divided by 7. Remember, whatever you do at the top, you want to do at the bottom. Nope, 28 divided by 7?
4.
It's 4. We found a common factor. The greatest common factor. Which means the highest one to get us to the lowest version of this, the lowest equivalent fraction. So we just brought this all the way back down. Right? And now, because look how many times we went over. How many of these do we have? 1, 2, 3, 4, 5, 6, 7. So what about this one then? What should we divide these two numbers by? 18 and 24. What should we divide those by to get back to 3/4? Ariana? 6. That's right. That will bring us back to the same number, 3/4. And then the next one?
5.
That's right, 5. And the next one?
4, 3, 2, and 1. 3, 2, 1.
That's right. Because divided by 1, you're going to have the same answer. See what I mean? You see that pattern? There's another pattern. You guys are getting really good at noticing patterns. Madeline.
So this is equivalent fractions into a simpler form?
So, I'm really glad you said that. I'm glad you said it that way. Because what will happen is in the future, you're going to get a fraction like this. Like next year when you guys get into 4th grade, for instance. And we'll do some more of it this year as well. But you're going to be asked, Aiden, please turn your body so you're not looking out the window and you're looking forward instead. I may not be as beautiful as nature, but math is pretty rad. Okay, 21 over 28. 21 over 28. Sellers, face forward. I don't want you turning around making faces at anybody. You need to be focusing on your math. 21 over 28. If somebody gave you that fraction and said to you, I want you to simplify this, now you know how you would do it. You would simplify it by finding your greatest common factor. And the common factor, what's a factor again, guys? What's a factor, Ariana? A number in, that's right, a number in a multiplication equation. Is that what you were going to say? Good. So your greatest common factor here will help bring it down to the lowest version. You can't get any lower than 3/4. Make sense? So you simplified. You simplified. You found the lowest equivalent fraction. Yes?
Yeah, Ariana got started thinking about nouns for some reason.
You start thinking about what? Nouns?
Nouns for some reason.
Okay. Well, I mean, could be related. All right, let's take a look at this page, guys. Everybody go over to your building equivalent fractions page. No, I saw a little bit of confusion on this one. This is what I want you guys to do. I need you to use your imaginations here, okay? Because what we're trying to do is we're visualizing. We're going to switch to the next page, please. We are visualizing. Visualizing. We're trying to make things look the same on both sides. That's why we're using the fraction bars. We're using the models. In this case, the shapes, okay? Because this now, since it's colored in over here, imagine that these lines weren't here. And that you're only focusing on the whole shape, right? Now it looks exactly the same. See what I mean? If these lines weren't here, this would be the same exact thing. And you can do it if you needed to by drawing it out the same way over here, right? Oh, look at that. They're exactly the same. See what I mean? So let's take a look at the next one. So we have 1/2 equals 3/6. Now, guys, how do we also know that 1/2 equals 3/6? How many times does 3 go into 6? Sellers? What's the relationship between 3 and 6?
It's half of 6.
That's exactly right. 3 is half of 6, so 3/6 equals 1/2. Now let's look at this. Okay, so we need 2 of these colored in, right? And that's what our shape looks like now. But remember, we want it to look exactly the same as this one. So if it helps you to look over here and say, okay, let me draw out the lines the way they did them over there, you could do that. Now we can imagine it as 3, as being cut into 3, right? But how many is this cut into? What's our denominator on this side, Talon?
Cutting shading 4.
You do, but that's true, but what's our denominator? How many parts do we have, Talon? Total. Not just the shaded one, but the total. 6. And Talon, how many did we shade in?
Shaded 4.
So our fraction is?
4, 6.
That's right. And now look at the relationship between those numbers. Look at these. Look at the relationship here. How do you get from 2 to 4? What do you do to it? Jack? 2 is half of 4. And 3 is half of 6. So 3 times 2 equals 6. And 2 times 2 equals 4, right? So there's a common multiple there. Yes? Yeah, let's talk about this one. Oops. Wrong direction. So, I need to shade in 3 of these, right, Jack? 2. 3. And that becomes what I have. What do I do over here, though? 1, 2, 3, 4, 5, 6. Now, if you imagine it without the lines in it, is that not exactly the same? It looks exactly the same, doesn't it? So then, if I colored in 1, 2, 3, 4, 5, 6, we know that that's our numerator then. But what's our total then there? What's our denominator, Jack? 6 eighths. And what's our relationship between 3 and 6? John? You can. What's our relationship between 3 and 6, Schmidt? That's right. And wait, 4 is how is 4 related to 8? That's right. So 3 times 2 equals 6, 4 times 2 equals 8. That's right. We found another common factor there, right? Okay, so this one here, Talon, you said you wanted to do this one here, so I've colored 4 over here, correct?
Yes. I colored in 2 on top and 2 on bottom.
Now what do I do on this side?
Color in 2.
That's right, because if you pictured it like this, now they look exactly the same, don't they?
And there's 5 in all.
5 in all. So what's our top number? Our numerator, Talon?
5 and 2.
2
Fifths.
2 fifths. That's right. Everybody got that one? Okay, and Schmidt, you said you were interested in this one. So we colored in 4 on this side, right? Did you do it the same way as the top one? So like this? And what about on this side? That's right. And now, of course, if we drew the line across, they look exactly the same, don't they?
Yes.
Well, what's our fraction on that one, Schmidt? 2 6, that's right. And again, the relationship is the same here, right? 2 is half of 4, 6 is half of 12. Do you see the pattern, guys? This helps you answer this bottom question. How could you know the fractions above are equivalent if you do not have the models? So if I got rid of the shapes and I wrote those in the middle and said to you, are all of these equivalent fractions? How would you know? How would you know? Madeline? You could draw them out. You could draw them out. If the models weren't there, you could draw them. That's true. But what if you didn't draw them? How else could you know? What have we been looking at? Ariana? Find a common factor? Right? See if you find a pattern too, right? We could find a pattern, couldn't we? Because look at this one. What if we started out with 2, 6? You guys don't have to write this here. I want you to actually write a sentence. But I'm using that area just for right now. So if I said 2, 6 equals 4, 12, what would come next? What's our pattern for the denominator? What are we counting by? What are we counting by there? Abigail? What are we counting by for our denominator on the bottom there? F 2, 6 equals 4, 12. Are you working on this page right now or are you doing something else? Ah, looks like you're doing something else. Okay, you should be following along. So what's our pattern? 2, 6 equals 4, 12. What's the pattern for the denominator? What are we counting by, Abigail? We're counting by 6s, aren't we? We're skip counting by 6s. Now for the numerator down here, Ian, what are we counting by?
4.
Nope, they're not 4s.
2.
2s. 2, 4, so it's going to be 6. What comes after 12 and 6s? 6, 12. Jack? Not 16.
Oh, no.
18. That's right. And we have 2, 4, 6, 8. And 10. But what's after 18? What's after 18, Schmidt?
24.
Right. What's after 24, Talon? Not 32. You added too many.
And,
Wait, hold on. What is it? What's after 24? You say 30? That's right. Because look at it, guys. How many do we have here? 1, 2, 3, 4, 5. 5. What's 5 times 6? What's 5 times 6, guys? Everybody?
30.
That's right. 5 times 6 is 30. What is 4 times 6? 4 times 6.
10.
4 times 6.
24.
That's right. What is 3 times 6? What is 2 times 6? What is 1 times 6? You guys see what happened here? Good. And the top again, we were counting by 2s. Does it make sense? Make sense, guys? Thumbs up if it kind of makes some sense. If you're starting to get it. Sideways thumb if you're like, okay, I need a little more work on this, but we're getting there. I'm starting to see the pattern. You love it? Some of you like it, some of you don't like it. You're starting to get there, but you don't like it. No. Well, we will be doing more of them. Now, let's quickly go back to, everybody skip back to yesterday, to this page here. Go over really quickly. We're on this page here now. Number 9. Number 9, yes. Did I not print this one again?
No, you did.
That's okay, we'll figure out where it is. Okay? I want everybody on this page. Now, number 9 says, Bradley had 40 slices of pizza to share. Remember, underline, highlight, circle the important information. Usually numbers, right? And keywords. He wants to share the 40 slices of pizza. How many pizzas did he have? And then explain how he solved it. Explain it in one complete sentence. Right? Gaps, capitalization, accuracy, punctuation, and spelling. Each of Bradley's pizzas was cut into 8 slices. Always look for the other information they're giving you on the page. Do not skip over these guys over here. They're telling you something. This is like a text feature, just like in what we just did that close reading on, right? It's a text feature. Now,
I can barely breathe.
you can barely breathe or read.
Breathe.
Breathe. As in, that kind of breathing? I understand. I'm having difficulty as well. but we still have to move forward. So,
I have a question for you. Would you share the pizza or would you eat it all?
I could not eat 40 slices all to myself.
Honestly, I could.
I might look like I can, but
Yeah.
okay, guys. Bradley had 40 slices to share, and it said his pizza was cut into 8 slices. What is our operation here? What's our operation first, Schmidt?
40 divided by 8 equals 5. Rainy has 5 pizzas. How do you
Good, and you give us your sentence. Perfect. Exactly right. Is that what you guys all had as well? Perfect. Don't get thrown by there being multiple questions or thinking there's not enough information or problem. I know a lot of people look at a word problem and they think, oh no, I can do this with words. Words are numbers, they don't go together. But they do. And 40 divided by 8 equals 5. So Bradley had 5 pizzas. He had 5 pizzas. He had pizza party. Now, let's look at number 10. Now, I didn't write the sentence here, but I do want to see that you guys have a sentence. Okay. Number, too far. Number 10. What was that? Wait, hold on. Miss Owen has 15 magazines to share among 5 students for our project. How many magazines did each student get? And then use the bar diagram to solve. Now, guys, I noticed on the math test, really quickly before we get to this, that there was a little bit of confusion. You guys know that if there is a number on the top of a bar diagram like this, that's your big number, right? So if you're doing division, they're giving you the number that you are using to divide, right? Okay? Now it says 5 students here. That means there are 1, 2, 3, 4, 5. So you know how many students there are, you know how many magazines there are. What you don't know is how many magazines each student gets, right? Madeline, how many does each student get?
5 divided by 15 is 3. Every student.
It's 15 divided by 5, not the other way around.
Every student gets 3 magazines.
Perfect. Every student gets 3 magazines. Just remember that it's not 5 divided by 3. Excuse me, it's not 5 divided by 15. It's 15 divided by 5. Because 5 can't be divided by 15, right? You can't divide 5 up 15 times. But you can divide 15 out 5 times. And that's what she told us right here. 15 divided by 5 is 30. Each student gets 3 magazines. You are correct. Now, let's take a look over here. Yonita has 28 different apps on her computer. Casey has 14 music apps and 20 game apps on his computer. How many more apps does Casey have than Yonita? Now, did they give us some information in this problem that we do not need? Did they give us information we don't need? Yes or no?
Yes.
Yes, they did. What's the information we didn't need, Sellers?
The music app.
We don't need to know that they're music apps or game apps. All we need to know is that they're apps, right? So don't get caught up in it saying music or game. Now, what's the operation that we need to do? We actually need to do a couple different things. We have this is a 2-step problem. It's a 2-step problem, right? Shmir, what's the first thing we have to do?
Really, I just counted what I
Well, first you have to find out how many Casey has, right? Because it doesn't tell us how many in total Casey has, so what do you have to do?
Oh, I added.
You have to add first, right? So you have to add 20 plus 14, which is 34, right? Okay, so Casey has 34. Now what do we do next? What do we do next, Jack? You do what? Well, we already took the 14 and 20. We added those together. So we got Casey's number, right? Casey's apps. And what do you think your number? What did you get for an answer, Jack? You got 14? Well, let's take a look. There's another step here. There's another step. What's our other step, Natalie?
I was going to say it's not 14, it's actually 12.
Because
You're subtracting.
you're subtracting Yonita's apps, right? Because the question is, how many more apps does Casey have than Yonita? So we're going to borrow from the 3. 14, 13, 12, 11, 10, 9, 8, 7, 6, 0. It's actually not 12. It's 6. Jed, what'd you get? Good. Good. So then we would say Casey has 6 more apps than Yonita. You guys see that? Always double check your subtraction. Now, let me ask you guys, do you do your subtraction the way that I do it? Do you line it up? Because it's going to make your lives way easier if you do. Always start on the right side. Borrow if you need to. Don't forget that you borrowed. That's why I write it out. Right? Okay, Ariana. Good, I'm glad to hear that. Okay, now we're into some fractions here, number 12. How can you tell just by looking at the fractions that 2/4 and 3/4 are not equivalent? Just by looking at them. Yeah.
The numerator is bigger or smaller?
The numerator is bigger or smaller? What do you mean?
I mean that 2 is smaller than 3 and 3 is bigger than 2.
You are correct. That's right. And because guess what? They have the same denominator, don't they? So obviously 2/3 and 3/4 cannot be, 2/4 and 3/4 cannot be equivalent. Because one is, he's right, one has fewer. Look at this one actually equals 1/2, right? And 1/2 and 3/4, those are equivalent. Even more than 1/2 right here. So this is really what they are. Make sense, guys? Everybody get that one? I hope so. Okay. Fiona and Gabe each had the same length of clay. Fiona used 2/3 of her clay, using 6. Now, when they say 6, guys, what do they mean? Alan?
Is this Fiona from Shrek?
This is Fiona. It could be. It's the same name. Using 6, what fraction of the length of clay will Gabe need to use to match the amount Fiona used? So where are we being asked here? What are we being asked? Ariana. We are being asked to find an equivalent fraction. You're right. 0, 0, 1, 1. Now, Fiona's was divided into thirds, correct? 1, 2. And she used 2/3 right here. 2/3. Now, Gabe's though it says 6. So what should I, can you please stop playing with the wall, with the whatever you have? Okay. It's your pencil, you should be using it to write, not play with over there. And if being by the window is going to be distracting, we'll move you back over here. Okay? We have 3 sections here. What do we need if we're using 6? How many sections do I need around? That's right. 1, 2, 3, 4, 5. Now we have 6 sections. So which one is equivalent to 2/3 then? What's equivalent to 2/3? Shred? Please put your chair all the way on the ground, Joel. Remember that day you fell? I don't want to see it again. This one?
Yes.
That's not equivalent to 2/3.
Oh, sorry.
You sure about that? Is it right here?
Yeah.
What's the fraction? What's the fraction? That's right. That's okay. But take a look at it, guys. You can always double check this, right? There's a pattern here. What's the pattern? What is it? Abigail, what's our pattern here? Are you on this page? Are you following along? What's our pattern here, Abigail? Do we have a common factor? What is it? It's 2. 2 times 2 equals 4. 3 times 2 equals 6. Or the other way around, if we were trying to go from 4/6 and simplify down to 2/3, we could say 4 divided by 2 equals 2, and 6 divided by 2 equals 3. Right? So you can always double check. Now, that's not what I'm looking at. Here we go. Which fraction is not equivalent to 3/6? Out of the ones below. Which fraction is not equivalent to 3/6? Have we go?
Third.
2/3 not equivalent to 3/6. What do you guys think? Think she's right, Ian?
I think it's 2/3.
So Ian and Abigail both say that it's 2/3. Anybody have anything different? Alan? 2/3?
I'm doing
Yeah, Joel?
2/3.
2/3? Brewer? Anybody else? Anything different? Shouldn't be, because the answer is 2/3. You guys guess what? 36 is equivalent to 1/2. 2/4 is equivalent to 1/2. 4/8 is equivalent to 1/2, which means that A, C, and D are all equivalent to 3/6. Right? Okay, next one over here. Which fraction is equivalent to 4/8? Which one of those is equivalent to 4/8? Joel?
2/4.
That's right. None of the other ones are. Is that the ones you guys got? Yes. Good. Good. Okay. Do you have any questions on the math for today?
No.
Any questions on the math? Okay. Good. So, we've got a good head start on our day then. We made really good use of our time today, which means we are right on time for ELA. So, go ahead and put your math away, which actually just means turn over to the spelling test page.